He's already paid the $20, but the prices still don't seem to fit. One item is more than another. Two together somehow outprice the third by a weird amount. And yet this can be solved in your head. How? Here's the setup. One shopper buys exactly three things: a cape, a hat, and a pair of galoshes. Altogether, the bill comes to $20. That part sounds harmless, but this puzzle gets strange fast, because instead of giving the prices directly, it gives only comparisons between the items. So we know the grand total, we see the three objects, but we still have no idea what each one costs on its own. Now for the only two clues. First, the cape costs $9 more than the hat. Second, the cape and hat together cost $16 more than the galoshes. That is all the information you get. No algebra required, no equation grid, just these relationships. Somehow, from those two comparisons and the $20 total, each exact price can be found mentally. But what do you replace, combine, or compare first to make it click? Start with the second clue, because it compares a pair of items to a single item. The cape and hat together cost $16 more than the galoshes. So imagine swapping that cape plus hat pair out and putting in another pair of galoshes instead. The total must drop by $16. Since the original bill was $20, the new bill becomes $4. And after that swap, what's left on the page is simply two pairs of galoshes costing $4. Once two pairs of galoshes cost $4, one pair must cost half of that, which is $2. That already gives us one exact price. Now go back to the original purchase total of $20. If the galoshes account for two of those dollars, then the other two items together must make up the remaining 18. So without solving for either one individually yet, we now know something very useful. The cape and the hat together cost $18. Now use the first clue. The cape costs $9 more than the hat. So inside that $18 pair, imagine replacing the cape with another hat. Since you are swapping a more expensive item for a cheaper one, the total drops by exactly $9. 18 becomes 9, but after the swap, the pair is no longer cape plus hat. It becomes two hats together, so two hats must cost $9, which is the key simplification. If two hats cost $9, then one hat costs $4.50. From there, the cape is easy, because it costs $9 more than the hat. Add 9 to $4.50, and the cape comes to $13.50. The galoshes were already found to cost $2, so the final prices are complete. Galoshes $2, hat $4.50, cape $13.50. Everything checks perfectly against the original clues. This puzzle works by exposing a hidden shortcut your brain almost misses. If you love price paradoxes and false assumptions, click the video on screen for another mystery that looks simple, until it completely twists your logic.